Good evening, everybody. It's Paul Daniels here with What I Fix Daily, and today we're going to be fixing my multimeter. Not that there's actually anything wrong with it. What instead we have is that I've been trying to get this to work on the serial port, and those of you who have been following my live streams will have noticed that I can get it to work on the serial port, but only if it's one of the traditional actual COM ports on a PC, which has got like the 16.5 250 5520 UART chip, things like that. But as soon as I use something like this, the PL2303s or whatever, it just doesn't work. I get gibberish. It sort of looks like it's right, but I can't make any pattern out of it. Yeah, it's just a mess. So I thought, okay, maybe it's a bit of crap. And then I tried this one, which is another one I had lying around, the same result. And I thought, oh, okay, it's probably because they're PL2303s and there's maybe a driver issue. So I bought a proper FTDI one, and it also didn't work. So at this point, I'm losing my crap. And it's just been one of those weeks where things are getting in my way, and there's some deadlines I've got to meet towards close to the end of the year, and every day counts, and people are just really starting to cause me grief. So when you're trying to do something important and everybody just keeps ignoring your request to let you get things done. Anyway, so here I am instead doing a YouTube video. Yep, that makes sense, Paul. Yeah, nice little hypocrite there. So I went along, and the next step I thought, fine. Oh, that's right. So what I sort of am deducing at this point is that the power requirements to drive the adapter that's in here, particularly with the infrared emitter, is too high for what these things can deliver, or the voltage is too low. I'm not sure if it's a power or voltage issue, but nonetheless, they just can't do it. So I modified the existing board and changed its capacitors. It had tantalum capacitors, or tantrum capacitors as I like to often call them, because you look at them wrong and they literally do chuck a tantrum. And I tried all sorts of things. I changed them over to ceramics and everything, still didn't work. I stripped the board completely off as my next step, leaving just the emitter and the receiver there. And then I wired it up to this is a 5-volt FTDI USB to serial converter. Actually, no, this is a TTL converter, not a serial one. The difference is that the TTL just works on 3.3 or 5-volt signal for RX and TX, whereas the RS232 versions, they have an additional chip on them which does the level conversion between the 5-volt or TTL logic type levels up to what a normal RS232 port will handle, like 13 volts or so, plus and minus. So so this is just it's a serial protocol, but it's not RS232. So I did that, hooked that up, tried a bunch of different values. That didn't work. So then I thought, okay, maybe I need some special driving for the emitter element, and so I put a 2-stage common emitter buffer on here, and it still didn't work. And at that point I pretty much lost my shit and threw everything up against the wall. Not really this, I didn't really, but psychologically I did in my head. So today, new day, I'm going to try something new. Instead of doing this optical interfacing here, I'm going to take a big risk and directly connect it. So get the casing off. This is actually a very good casing. One thing this Protek608 has that beats all the rest of them is a proper kickstand. And I mean, this is a good kickstand. I've got some other meters that have got kickstands, and you sort of go, and they fall over. Look at this. You can't knock that thing over. Right now, Lewis is going to be jealous as hell. This is exactly the sort of thing he wants. A kickstand that can cope with that. But you can't get it. And you can't buy these meters anymore, which suck. Alright, let's get this apart. These are the emitters. Transmitter is on this side, receiver on that. I can show you how I know that. One of the nice things about cameras, as in recording cameras, is that they pick up infrared. Not long wave infrared, just short wave infrared. Let's go menu, turn on the RS232, let's have a look. You should be able to see this. Alright, so there you can see that it was transmitting light pulses relatively, well actually not relatively, exactly the same rate at which we normally receive the data. So let's get this thing open. Now the reason why this is a big risk, me doing this, is because the purpose of the optical interface is to isolate the meter and whatever you're measuring from your system, whatever you're connecting up to. Now even if your computer and your equipment are connected up to the same power board, there's still floating grounds and they will still be at up to thousands of volts difference between them. So when you bring them together, as in if you're measuring one thing and it's plugged into the PC, you're forcing those grounds to have to come together or match up, and that causes a nice little bit of a shock and potentially damaging your equipment. So that is why we use optical interfaces. Doesn't matter if the meter itself is battery powered, it's still the same problem. So this for me is going to be a testing case. I am going to modify it to verify that I can legitimately read the protocol out of here properly, and if that is the case, then I will take it another step and get myself a wireless serial transmitter. We'll get to that later. For now, let's see if we can even get this thing to work. So this here is the transmitter. I am not going to meddle with the receiver. The reason being is that I'm not sure what the logic talking to that or sensing that is going to be. So I can't just put a 5 volt logic line, digital input into there. That'll be for another day. Not that you really need it. Most of these meters are just simply output and no input. You can use the input on this one. It allows you to turn on the backlight, it allows you to hold the value, it does a few things, but nothing that we're using. First thing I want to check is what the voltage level is on this, which leaves me in a bit of a predicament. How do you measure the voltage of that? You need another multimeter. Thankfully I have one. Okay, we've got our other multimeter, and this is a piece of junk, $12 special, where I have to work out what voltage levels I want. Okay, and the kickstand on this is more what you'd expect from cheap nasty multimeters. Look at this. So, oops, yeah, horrible. Right, where's my battery going for this? There it is. Really, how hard is it to make a proper kickstand, for God's sake? Hopefully this thing turns on. It does. I might kill that buzz beeper. Menu. Let's go RS232. Alright. Now hopefully this little piece of junk will be fast enough. Okay, this is ground. And that's ground. What's that? Zip. Yeah, you're not even close to being fast enough to pick that up. Alright, that's not going to work. Fortunately I have another option. This lovely piece of equipment, which is my old handheld oscilloscope. Might get a zoom in on that. It's one of my big investments about 10 years ago, and yeah, I don't really use it as much as perhaps people would think. So we're going to run, we're emitting, so let's have a look. Really not getting a lot here. Why not? Oops. The voltage is rather low. It'd be an indication of around about 0.4 volts, which is a lot less than what I would expect from a infrared emitter. Normally you'd be looking at 1 point something volts. Interesting. Well, one way around, we can remove the emitter and replace it with a resistor. Or we can just remove the emitter outright. Let's see, can we do, might have to do hot air here. Let's see how we can go now. Great, showing nothing almost. Well, I find this interesting. That line that it's connected to is elevated. So perhaps what we have here... What are you? Oh, I think we might have this. Okay, I would appear to have potentially misinterpreted how this meter is rigged up. I was under the impression this was a ground line, but perhaps it's not. And in which case then the meter, in order to activate, is sinking low. That's going to be a real, hilarious. Not really what I want. What can I do? What can I do? Get our meter back because it's got probes that I can use. Yeah, that's ground. Oh, interesting. So there we go, 5 volts, well, 4.5. What about you? You're more in this, oh bloody hell, but you've got split rails, which is understandable because in a multimeter you need to be able to measure positive and negative voltages, and therefore your input needs to be able to, your op amps need split rails so you can go both sides for the digital converter, analog digital converter rather. So in this situation what is happening, I'll just disconnect this before I make a mistake. What is happening is power is supplied to the LED up here. So we've got the plus 5 volts, and then when the meter wants to let out a light pulse, it pulls this line here down to ground through whatever chip is there. And when they do that, it lets the current flows causes the LED to light up. So us attaching a wire to here is not going to do us any good at all. That is one of these pain in the butt things that I don't like. It's so much easier when it pumps 5 volts to it. Now the reason why it's a pain in the butt is because if we put a resistor here, say 10k or something like that, then that line is going to stay high while there's no pulse, and then as soon as it pulls down it's going to go low. We also don't know how low it's going to go, but we'll assume there's about a 200 ohm or maybe 300 ohm resistor in there between them. So yeah, it's going to be the inverse of what we want. What a nuisance. I wonder if the USB adapter is smart enough to realize it's an inverted protocol. I have seen software that allows me to adjust the polarity or the state of these devices, the input lines, so you can have it so that RX is reversed or TX is reversed. Okay, so what I'm going to do is I'm going to, that was my little beeper, and this time I kept it nice and quiet so I didn't lose my hearing. I am going to put probably about, say, a 50k resistor there. It's way over the top, but that's fine. We don't really want any current going through here. What have we got here? A small spool of 200k resistor. That'll do. Mind you, they are 603, and that looks closer to, it's definitely 0805, maybe 1206 potentially. We'll see. I'll fit just. Where's my wick? I will point out this is actually a pretty good time wasting exercise with no financial rewards. The smart thing to do is just go get a meter that does what I want already. Okay, let us now check that that works. At least the meter still beeps, so there's a good sign. Menu. Okay, let's have a look and see how it goes. You can see the pulses coming through here. This is the serial data, and you can see it's inverted. It's going from elevated voltage and being pulled down. It's fairly noisy. I don't know if that is just the probe not doing its job so well. I'd imagine so. A lot of noise in there. Okay, so that at least we know is one step forward. I will remind you, we are hoping that our USB connect trans bridge thing here, we are hoping that it will be smart enough to be able to invert that logic. Otherwise I have to end up, shit, just realised that's still on, idiot. Otherwise we'll have to end up putting it through an inverter, which is not a major pain, like major pain, but it's a nuisance. Now I have to just get my wires off here, and since I can't really see them, I'm just going to randomly move my soldering iron tip around until they come off. Marvellous. Put that piece of junk over there. Let's go back to this. So for this we have three requirements. We need a ground, signal, and positive. Now thankfully we worked out that that is positive. And on this, yeah, I don't need positive on this, because this is self-powered. So in fact the last thing we want is power going into this. That'd be a nice conflict. I believe your ground, your receive, your VCC. So we don't need that, we need 2 wires. Good thing I thought of that. Which one's which? Okay. Receive. Remember we're doing this on the inverted side. So that'll be there. Add a little bit more flux, because that old flux will be burned off a bit. For those of you who keep asking when I'm going to get my microscope, unfortunately it's a case of simply, financial limitations. Believe me, I do want that thing so bad, but there's certain realities you have to deal with. Wanting something is not the same as being able to just go out and grab it. I need a proper place for ground to pick off. One of these is going to be ground. The other option, of course, is to scratch out ground. I might well have to scratch out ground. Okay. Just find ourselves a little spot. Don't need a lot. This is a little bit dangerous, because if that is required for category 3 rating, insulation, etc., then I've just pretty much ruined it. To be fair, I'm not planning on using this for any high voltage stuff. Alright, we're done. Our ground, have our receive. I guess now we need to plug a serial cable in and see what happens. We're back. We're at the workstation. I've just plugged the meter in, turned it on, switched it over to USB, so let us see and pray to the gods that I don't believe in, maybe except the noodly appendage one, to see what we get. For Linux I like to use QCOM. It's amazingly good for doing this sort of work. Now I have previously, we've got 9600, no flow control, we've only got the RX line anyway. Read write, again irrelevant. 7 bits, no parity, 1 stop, USB 0, so at least I know the device I purchased, that FTDI adapter, works. Guess here we go, open. Permission denied. Oh yeah, of course. Damn it. Okay, let's try again. Fingers crossed. We have a bunch of gibberish. Oh wait, I can see. Yes, we must be working. Our brackets here. These open and close and square brackets are the delimiters for the framing. Let's change over to hex output. Let's have a look. And that looks proper normal. Okay, so we've got why don't all the brackets always come up? Am I missing something here? See how they don't always come up? I don't understand how it's... The brackets should be 5D, 5B, so they should be appearing there. I don't know why they're there. Maybe this program's got a bug in it. Oh well. Well, best way to tell is to run the software itself. I'll probably have to be root to do this too. Someone broke their display. Okay, that's fairly sure that's reading, but like an idiot, I put debugging code in there. Probably when I was trying to see what was going on. Now, where did I put my debugging? There we go. I really should make a make file for this, because in the past I have made mistakes where I've accidentally overwritten my source code by doing something like that. And once you press enter, it is dead. And I'm amazed that worked. ACDC, we're showing a lot of gibberish here. It's somewhat nonsensical. Let me just switch modes over to millivolt, because I know millivolt always gives me a good... There we go. No, OL is not correct. Could this be to do with the... Yeah, I was mentioning that there's a lot of noise on there. I know that is showing OL. What's going on here? Alright, let's go to diode mode. I know that will always give me like 14 or 20. Okay, yeah, we've got proper value there. And then we lose it. And then we're back to proper value. And there is a lot of data mangling going on here. So we're close. Okay, it's switched over to diode mode properly now. Now see how see that data back there is what's getting mangled. I'm not exactly sure what's going on. Perhaps well, that's far from satisfactory, but at least I know that the connection itself can theoretically work. That data is being mangled still, and I'm not precisely sure why. I don't know whether it's because it's inverted, which is causing confusion, or whether it's because of the noise on the line that we could see. But that noise would be quite unusual. Yeah, maybe my ground's drifting. That doesn't seem right. It could be that my 200k resistor is too high, so well, let's go change that to say something like a 12k. At 12k, it's still not a large current draw. Certainly it's less than what that LED would represent. Let me just work that out. 12,000. Yeah, it's less than a milliamp. It's not going to hurt anything. It could be that the impedance of the line is too high. So let's go check that. We've changed over to about 10k impedance. Let's try that again. And pretty much diddly fuck all difference. Fuck. What the hell? If anything, in fact, it seems worse. I just don't get it. 5D, 5B, 5D, 5B. Something's not right. Alright, I'm at it again. I can't help myself. I need to solve this because it's driving me insane. So what I'm doing this time is, instead of coming off the where the power comes in for the LED, I'm going to go looking for the signal line. Now there's a veer over here, and I'm going to find out where it is on the other side. The easiest way to do that, in this case it looks like the veers are all the way through, which is normal. It's only a two-sided board, and hopefully this little bit of, yep, there we go, goes through, and let's see where that comes out. Alright, what have we got? Well, it's a hell of a change from the usual main boards I'm used to dealing with. So we've got it coming out of here. Looks like that line there. There would be a MOSFET or a transistor. Your 220 ohms and 10K. Okay, so this will be the signal line as to control the gate or the base. I'm not sure whether that's a MOSFET or a transistor, BJT. So we don't really care about the power line. We want the signal line. So what I could do is, I might pull that. I'll pull this resistor off. I'll pull the MOSFET off, the transistor off, and then we'll tap into this signal line. Hopefully we'll get a better reading there. So for that, use the hot air. Let's go up to 460, and drop our air down to about 30%, because anything else is an overkill. I better put this somewhere just in case I want to get it back. Oop, that came off way quick. Gotta remember that when dealing with these two-sided boards. Things do come off very quickly. Where am I going to put you? Where am I need to find a little container for this. Alright, I've got our little container. I'm just going to drop that transistor in there. They are still strictly speaking transistors, even if they're MOSFETs. MOSFET's just a kind of transistor. Alrighty. I'll pull that wire back out since we know where we're going. Might as well remove that transistor, the resistors as well. Yeah. Wonder if we can fit the tool with it sheathed. You're gonna go in there. Hey, you actually did. Amazing. So where I want to connect it to is here. It's before the 10K resistor. So the reason why I want it before the 10K resistor is because I don't know what sort of impedance I'm dealing with. Nope. Okay, sorry if this is going to be out of camera range, but okay. I'm just going to have to sad thing is I can't really test this prior to using it. Okay, that should do the trick. I think we're good. It's a terrible joint. Terrible. So Lewis-Rossman flux is just, it's oozing everywhere. It was like an hour ago I squeezed this and it's still coming out. Alright, let's give this a bit of a test. Let's see if we're any better off. Alright, we are back again with the modified multimeter input. So there we go. I'm starting to lose hope here, but oh well. And we got gibberish. Great. Let's have a look at the cute com. Hex. Open. I mean, I'm seeing the pairings and the bracketing is as it should be. I don't know what the hell's going on. When the data looks about right from what I'm expecting, so I don't know why I'm coming up with this, unless it's very hard to understand what will be going on here because it's just LCD segments that it's representing. You can't make an assumption that anything over say a value of 4, if it goes into gibberish, maybe it's a bit being blocked out or something, because it's just there's no correlation. Let's have a look at the code. Bring that up. Let's get that font a bit bigger. 14. Thank you very much. Have a look at my serial code. Get rid of that. That strips the top bit from the data. Now 5B, that would, I think, no, that wouldn't fit. Let's give it a go anyway. What the hell? How bad can things go at this point? I mean, it could be something else. It could be parity ignore, which is fine. Ignore line return, which is fine. I've got my That's what I should just see. And did I compile that? Yeah, gibberish. What the hell's going on here? I better check my meter, make sure it's actually reading. Yeah, we should be seeing 28065. So we should probably have also there's a function I want to call called make raw, which sets all the settings to be quite raw. Where are you? CF make raw, that's the one. Oops. Oh, hello. Hello, we're working. Are we really working, or is this just a trick? I don't know about you guys, but and girls, of course. Sorry, I say guys when really I mean everybody. It's like a group. That's for another discussion. Um, I don't explicitly trust this at the moment, because what's to say it's just temporarily in some sort of phase where it is working, and then I come back later and it no longer works. I've been caught out plenty of times in doing software development with that sort of thing. You're like, yeah, it works, ship it. And you ship it, and then all of a sudden you find, no, it doesn't work. It's too late, you've already shipped it. Yeah. Not so much of a problem these days with the internet and whatnot, but back when you had to burn CDs full of stuff, like before USB sticks, yeah, it was a pretty big commitment making a shipping version of your software. I mean, yeah, you could put it on the internet back then. It was very slow if you had like a megabyte or two. Well, it's still behaving. Let's try change our meter, which is a bit of a Frankenstein right now because all the back's off it. Ohms. OL. Yes, we've got OL. Millivolts. OL as well. I could probably stick my fingers on. Let's see. Fingers. How about there? Come on, surely I'm worthy of a couple of millivolts. No, not me. Volts over capacitance. Nothing. Frequency. Nothing. Voltage for that. Nothing. 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 Let me plug my leads in and see if I get anything from millivolts. Looks like the battery's running pretty low now. Oh, one thing that will improve is now that I've removed the LED, the infrared LED, serial mode will go for quite a while. There we go, some millivolts. Should be reading 2,390 or so. What have we got? 2389. We're right on the mark. Beautiful. Okay, well, shocker. Oh my god, can't believe it. It's working. Oh no, I'm over limit now. What? Yeah, I really am. Ohms. I think my battery's on the. Oops, I nearly ripped out the cables. Let's go for a short circuit. Nothing. Have I damaged my meter? I think my meter reset. Menu. Turn on RS-232. Zero volts. How about millivolts? Ow! Well, I don't know if my meter's on the verge of not working, or maybe I wonder if my RS-232 thing is manipulating things. Maybe I'm influencing. No, if I was influencing the display, I'd be getting gibberish on the actual meter. I have a feeling my battery just might be too flat. Alright, we're back with a better meter battery. And let's turn her on to millivolts. I'm getting something more of a reasonable reading. Serial on, and I'll straight away go to OL. Yeah, everything's showing OL as soon as I go to the meter, so I think I'm going to have to I'm going to have to move that pickup line to the other side of that 10K and see what happens. Yeah. Okay, I think I found the problem. There was a when the data was coming out funny, even after I was picking up the direct line from the out of the processor or whatever they've got in there, I thought maybe it was a pull down problem, as in because it was trying to turn on a MOSFET, perhaps there was a 10K resistor or something like that on the line through from the gate to pull down to ground. So I replicated that on the USB stick, but I think that was the problem. It was creating an odd load for the device. It's probably going to be USB 0 now. Let's reset that. There we go. 604 millivolts, is that what we got on display? Yes, we do. Okay, wow. I'm shocked. I was very, very much about to give up. And it would appear now we have a working multimeter interface. Now, this is really just one step in a few yet to come, because as I have said before, I do not want to directly interface this unit, because otherwise it'll cause issues. I've got two choices. I can make an optocoupler on this line and that will work, or I can go for my preference, which is to get one of the Bluetooth serial modules, and all they do is they just basically act like the USB module that I've got right now. And let's see if we can bring up the Chromium. Bluetooth serial. Here we go. Out of stock, how lovely. Anyway, it'll be a device like this, and it simply will take the serial input. It's usually about, well, it's just the two lines, and then we can hook it up to the PC through the Bluetooth interface. See here we got 9600 board. The default is 8 bits, which could be a little bit of a problem unless I can find out how to make it 7-bit. In which case, if I cannot, I will have to resort back to the optocoupler method. Now, the downside of using an optocoupler is we're back to using a lot more battery power again, but you do need to do that in order to get the safety. Yeah, it's a little more exotic than the others in terms of how it does, but essentially you'd have the multimeter on this side, and then you would have the USB port on this side. It's easy enough. Gives us 20 kV protection, and this is the nice thing, it only needs 1.5 milliamps, so probably about 2 milliamps would be right. That'll give you a good chance of some battery life. And this is why RS232 optocouples drain multimeter 9V batteries so quick, because a typical 9V battery is going to have around about 150 milliamp hour capacity in it. Now, the diode mode that we often use in it itself uses 1 milliamp hour, 1 milliamp, not 1 milliamp hour. And then you add on top probably closer to 5 to 10 milliamps for that particular infrared transmitter that we saw on the meter. So let's just call it a 10. And as you can see, you've then got basically 10-15 hours of continuous use before you run out. So yeah, that's why your battery gets drained so quick, and it's why something like a 2 AA battery combination is better. Alright, well, the meter's still going, so I'm going to call that a success. Bit of a crazy one, but it is. And thank you for persisting for so long. I'm going to have to put this meter back together and have a couple of cables dangling out of it for now. But probably, I must admit, at the end of the day, I'm still going to end up buying another meter. But it was a case of this was narking me, I wanted to solve it, and now I have. So thanks a lot. I'll see you guys next time.
Okay, so at the end of after all that, I thought to myself, well, if it ended up being a software configuration problem on the decoder, maybe I didn't have to go the extra step in picking off the data from the signal line going to the MOSFET, driving the infrared LED. So sure enough, I went back and I put the MOSFET, BJT, whatever it was, back on, and then I moved my receive pickup lead for the USB adapter. I put that back on to the other side of the 200k resistor. I put the 200k resistor back in where the LED was. And sure enough, it worked. So that was really good. It does mean, though, that I spent a good hour or so stuffing around on something I didn't have to. Which brings up an interesting point, and something that needs to be illustrated and talked about, is when you go about modifying equipment to try and save money. I really shouldn't use rabbit ears. Anyway. You have to take into consideration the fact that it could be a long goose chase and plenty of red herrings along the way. If you look at the time that I have spent initially trying to deal with the this particular multimeter, it's at least probably half a day collectively, maybe even a full day collectively. And if you convert that into perhaps jobs that I didn't do, then I could have easily bought a better multimeter right from the start. As such, when it comes to this sort of thing, I think it is useful in that respect to then release this sort of information to the public. I'm not going to profit from this, so there is no point to me keeping it for myself for commercial reasons. If it saves someone else out there from running around for a day or two, then all the better. I may actually end up saving them money. If I didn't save myself money, but it could save them money. And this is a sort of philosophy I use for a lot of my software, such that I write in the open source systems. If I am not going to commercially make money from it that I can see, or I don't have any plans to create a commercial product based on something, then I'm more than happy to put it out under BSD license or something similar so that someone else out there may be able to save money. It's not truly altruistic, is that how you say it? Because ultimately I am sort of hoping that I will encounter other people who will have done the same thing and thus save me time. And I admit, in the past, I have encountered a great deal of software libraries, packages that have been pre-done using, say, the BSD, X11, MIT type licenses, and yeah, they saved me a lot of money, a lot of time. So I guess you could sort of consider paying it forward or planning forward, either way. Anyway, so that's it in the end. A lot of running around, but it works, and I will probably still end up getting a different meter because I do want to have this one running wirelessly. I don't really want to stuff around with this too much more, but who knows? Maybe tomorrow I'll wake up and have a different mindset. Until then, I'll see you next time.